guys, welcome back to Calculus Universalis. Today we're going to be combining everything we've learned by the first and second derivatives to sketch graphs of functions without even needing a graphing calculator. So, this is one of the most tested skills in the AP Calc exam, especially on FRQs. We will review this strategy and then walk through 3 full examples together. Let's dive in. To sketch a graph using derivatives, you're answering 3 big questions. Where is the function increasing or decreasing? 2. Where does it have local extrema, max or minimums? And 3. Where is it concave up or concave down? Let's go through 3 full processes step by step. Let's go through the full process step by step. Number 1. Find f of x. F prime of x. It tells you where f is increasing. If f prime of 0 is greater than 0, then it's increasing. Find f prime prime of x. Find f prime prime of x. This will allow you to tell if it's concave up or concave down. 3. Find critical points where f prime equals 0 for D and E. 4. Build a sign chart for f prime and f prime prime of x. And then lastly, use that info to sketch the graph of f of x. So that's the full process. Now, we're going to be doing some example problems. Feel free to pause the video before I do them to see if you can find it yourself. Example 1. Sketch x to the third minus 3x squared plus 2. Go ahead and pause the video and try yourself. So now we know we have critical points at x equals 0 and x equals 2. We're going to test these intervals, and we find that from 0 to 2, it's decreasing. First derivative test, and when it's greater, it is increasing. From here as well. So this gives us that there is a, that's our step 1 here. Step 2, f prime prime. There's a point of interest at x equals 1. Right? 1. And it goes from concave down to concave up. Point of inflection at x equals 1. And then, now using this info, we can sketch the graph. Let's go ahead. It's gonna start increasing. We know it has a POI at x equals 1. Reaches its local minimum. It's going to be something like this. And then it increases again. Local max. So it's going to be like this. And this is what you need for rough sketches on your AP exam. Let's try a couple more problems. We're going to analyze this using f and f prime. So our function is going to be f prime of x equals x minus 1, x plus 2, f prime of x equals 2x. So f prime is 0, f prime equals 0, x equals negative 2, and x equals 1. So let's make a sign chart for f. Negative 2, 1. Going to be decreasing, increasing, then increasing again, which means we have a local minimum at 2, negative 2. No max at 1, nothing there. Concave up at x is less than 0, and concave down when x is less than 0. Sorry, concave up when x is greater. So it's a POI at x equals 0. And then we can use the sketch to make our graph. Let's go ahead and do this. Let's make our graph here. We're going to have minimum x equals -2. We're going to have POI at 0. And then curve bending upward after that. So it's literally just going to go up. This is what our graph looks like. Some of these are more complicated than others. This one's a little bit strange. Let's go for our third example. Given a graph of f of x, describe the shape of f of x. So, if I give you a graph, you have to describe the shape. How are we going to do this? We can use terms like concave up, concave down. Say it's concave down from here, point of inflection here, concave down, point of inflection, concave up. Then you have x-intercepts, you have x-intercept again, and then you can say it's positive, positive, increasing. This will be used for velocity and much after that. Anyways, here's the game plan for sketching graphs using derivatives. We're going to use f prime of x to find where f is increasing or decreasing and where extrema occur. Use f prime of x to find concavity and points of inflection and sketch based on shape, not just points. Your challenges are to sketch graphs, analyze functions, and determine extrema. Next time we'll shift into real-world favorites, optimization problems. Don't miss it, they always show up on the exam. Like and subscribe, I'll see you in the next one.